So after formation of differential equation, now we are going to talk about solution of differential equation. So solving a differential equation simply means finding a function which will satisfy the given differential equation. So here we have one problem. The question is verify that this function e to the power 2x, this is nothing but y equals to e to the power 2x is the solution of this differential equation. So as I have said earlier, the solving a differential equation means finding this function y which will satisfy this differential equation. So here we only have to verify that this is the solution of given differential equation. So y is e to the power 2x. Now what will be the value of dy by dx? Dy by dx will be nothing but 2 into e to the power 2x, and d2y by dx square, we again have to differentiate this, so we will get 4 into e to the power 2x. Now we have to show that for this function the left hand side will be equal to right hand side. See, there is one very basic concept that you need to understand. Suppose if I have this equation x plus 2 equals to 5, then what is the solution of this equation? The solution is x equals to 3. Why x equals to 3 is solution? Because when x is 3, your left hand side will be 3 plus 2 5, which is equal to right hand side. So if I substitute the value of variable here, then the left hand side becomes equal to right hand side, and therefore this particular value of the variable is the solution of this equation. So similarly here, if I have to verify that this y equals to e to the power 2x is solution of this differential equation, then for this given function we have to show that left hand side, which is this expression, will be equal to the right hand side 0. So if y is e to the power 2x, then our left hand side will be, left hand side is d2y by dx square minus 3 dy by dx plus 2y. Now in place of y we have to substitute e to the power 2x. dy by dx will be this thing, d2y by dx square will be 4 into e to the power 2x. So this will be 4 e to the power 2x minus 3 dy by dx is 2 into e to the power 2x plus 2 y is e to the power 2x. So now if you see this, the left hand side is nothing but 4 e to the power 2x minus 3 into 2 6 e to the power 2x plus 2 into e to the power 2x. So finally this will give us 4 plus 2 6 minus 6 0, which was our right hand side. So since for the given function the left hand side becomes equal to right hand side, therefore this function is the solution of this differential equation. So this question was basically how to find whether a function is solution of given differential equation or not. Okay, now we are going to learn how to find this solution, how to solve a differential equation, how to get this function y. Okay, so we'll start with the solution of differential equation of first order and first degree. There we'll see 4 different techniques, and then we'll talk about differential equation of higher order. Okay, so next we have to learn solution of differential equation of first order and first degree. In our in our earlier discussion we have seen what is the meaning of first order and first degree. If only you have dy by dx, then it means the differential equation will be of first order, and if the exponent of dy by dx is 1, then it will be a first degree differential equation. Now for these type of differential equation, there are different techniques to solve these type of differential equation, so that we are going to see one by one. Our first method will be variable separable method. Okay, so this will be our first method. Then homogeneous differential equation, linear differential equation, obviously linear differential equation of first order and first degree. We are only talking about differential equation of first order and first degree. So homogeneous, then linear differential equation. Then we will talk about Bernoulli differential equation. Now this Bernoulli differential equation is not linear differential equation, this is reducible to linear. Okay, Bernoulli is not a linear differential equation, but by some substitution we can reduce this to linear differential equation. And the last one is exact differential equation. So we'll talk about each one of these one by one. So our first one is variable separable method. Now here your differential equation will be in this form, dy by dx, this equals to some function of x multiplied by some function of y. Okay, if your differential equation is in this form, then you can solve this differential equation using variable separable method. So here the approach will be, you have to write the function of x with dx and function of y with dy. So you can write this relation as dy by gy, and this will be fx dx. Now you have to integrate both sides to get the solution of this differential equation. So suppose if the integration of this is capital G of y and this is capital F of x plus some integration constant c, so this will be the solution of this differential equation. Now let me explain this idea with the help of one example. Suppose if you have this differential equation, say dy by dx, this equals to log x plus 1 by sin y plus cos y. If you have this differential equation and you want to solve this differential equation, then here you can easily see that you can write this function of y with this dy and function of x with dx. So you can write this relation as sin y plus cos y dy, and this will be log x plus 1 dx. Now once you have separated the variable, once you have written the function of y with dy and function of x with dx, then you can integrate both sides to get the solution. So if you integrate both sides, then integration of sin y will be minus cos y, integration of cos y will be plus sin y. Here you have to integrate log x, and integration of 1 will be x plus integration constant c. Okay, first we have to integrate log x, integration of 1 will be x plus c. Now we have to see how to integrate this log x. So in order to integrate log x, we have to use integration by part formula. We have seen what is integration by part. Suppose if you have integration u v dx, then this can be written as u integration v dx minus integration of, now you have to differentiate this outer function, so du by dx, integral of v dx, and then you have to integrate this entire function. So this formula is called u into v formula, or integration by part. Now how to decide this u and v? So u v is decided by this islet rule, where I stands for inverse function, L for logarithmic, A for algebraic, T for trigonometric, and E for exponential function. So in this order, the first function, suppose if you have inverse and algebraic function, so this means inverse will be your u and algebraic function will be function v. So similarly here, if I want to integrate this log x dx, so this I can write as integration log x into 1 dx. So now, and you can see that this log x is logarithmic function, 1 is algebraic function. So here you can see that L is before A, so this means you have to treat this log x as u and 1 as v. So we can write this integral as log x integration 1 dx minus derivative of log x 1 by x integration of 1 x dx. So now this will give us, from here you will get x, so x log x minus these two will cancel x. So this will be the integration of log x. Integration of log x will be x log x minus x. So finally your solution will be, your left hand side is sin y minus cos y. Integration of log x is x log x minus x plus this integration constant c. These two will cancel, and your final solution will be sin y minus cos y, this equals to x log x plus c. So this will be the solution of given differential equation. Now whenever you can separate the variable, whenever you have some function of x multiplied or divided by some function of g, then in that case you can easily separate the variable, and then by integrating both sides you can find the solution of the given differential equation. So you can copy this, then we'll take some more examples on this variable separable method. Now we have these two problems from GATE previous year paper based on the concept of variable separable method. The first question is from GATE 2015 in AC department. The second one was asked in engineering services 2017. So we are going to solve these questions one by one. The first problem is, the given differential equation is dy by dx this equals to 1 plus cos y, 1 plus cos 2y by 1 minus cos 2x. One more thing here, the options are option A with minus sign, option B with plus sign, option C with minus sign, option D with plus sign. So first step will be, here we need to separate the variables. So dy by 1 plus cos 2y, and this will be equal to dx by 1 minus cos 2x. Now once we have written the function of x with dx and function of y with dy, we need to integrate both sides to get the solution. Now if you want to integrate this, 1 plus cos 2y, this will be 2 cos square y, 1 minus cos 2x, this will be 2 sin square x. 2 and 2 will cancel. 1 by cos square y will be sec square y dy, and here we will get cosec square x dx. Now integration of sec square y, this we all know is nothing but tan y, and right hand side this will be minus cot x plus c. If we rearrange this relation, then we will get tan y plus cot x equals to c. So this will be our option B. Option A is tan y minus cot x equals to c. Option B is tan y plus cot x equals to c. So here the correct answer will be option B. Tan y plus cot x equals to c. Now the second problem that we have from this topic is we need to find the solution of this differential equation. The given differential equation is y into root over 1 minus x square dy is minus x into root over 1 minus y square dx. So here again you can easily separate the variables, and once you have separated the variable, then you have to integrate both sides to get the solution. So if we separate the variable, then you can write y dy divided by root over 1 minus y square, and this will be minus x dx divided by root over 1 minus x square. Now you have to integrate both sides. So these two integrals are similar. If we take this minus sign outside, then you can see that here you have y by root over 1 minus y square, here you have x by root over 1 minus x square. So let me call one of these integrals as I1. Okay, let me call this integral as I. So I is suppose x dx by, we can solve this integral here. So let I be dx by, let I is integration x dx by root over 1 minus x square. Now in order to solve this integral, we have to do this substitution. Put 1 minus x square equals to t. So this means dt will be minus 2x dx, which means in place of x dx you can write minus dt by 2. So this integral will become integration minus dt by 2 divided by 1 minus x square is t, so this will become root t. So minus 1 by 2, and integral of 1 by root t, this will be nothing but 2 root t. 2 and 2 will cancel. Finally you will get minus, and root t is nothing but root over 1 minus x square. So this is the value of this integral, integration x dx by 1 minus x square, root over 1 minus x square. This will be minus root over 1 minus x square. So now you can see what should be the value of this first integral. This will be nothing but minus root over 1 minus y square, and from here you will get minus root over 1 minus x square plus c. Okay, so now if you want to rearrange this relation, you can write this as minus minus plus. So root over 1 minus x square, here you will get root over 1 minus y square plus integration constant c equals to 0. So this will be the correct answer. Now you can see that this is nothing but option C. Okay, whether you write plus c or minus c, this will not make any difference because c is only arbitrary constant. So here the correct answer will be option C. Now after this we'll talk about reducible to variable separable differential equations. The differential equation in those type of problem, you cannot directly separate the variable, but by doing some substitution you can separate the variable, and then we will follow the same approach. Okay, so next we have to learn how to solve a differential equation which are reducible to variable separable. So here the standard format will be dy by dx, this equals to some function of ax plus by plus c. Okay, and remember that in this type of differential equation, first see whether you can directly separate the variables or not. If you can directly separate the variable, then separate the variable and integrate on both sides to get the solution. But if you cannot separate the variable, then you have to perform this substitution, ax plus by plus c, this equals to t. Okay, in place of ax plus by plus c you have to write t, and then you will see that you can separate the variable. So for example, suppose if I had to solve this differential equation, say dy by dx, this equals to cosine of x plus y. Say I had this equation. So here if I want to separate the variable, then you cannot directly separate the variable because you have cos and x plus y is inside this cosine function. So here in order to separate the variable, you have to do this substitution, x plus y equals to t, because you have this x plus y inside cosine. Now if you write x plus y as t, then you also have to replace this dy by dx. For that you have to use this relation. So if I differentiate this relation with respect to x, I will get 1 plus dy by dx. This will be dt by dx. So this means dy by dx will be dt by dx minus 1. So now in place of dy by dx, I will write dt by dx minus 1, and in place of x plus y I will write t. So our differential equation will become dt by dx minus 1, this equals to cosine t. So this means dt by dx, this will be 1 plus cosine t. Now you can see that you have this function of t here. So you can separate these variables. You can write the function of t with dt. So dt by 1 plus cosine t, this will be dx. Once you have separated the variable, you have to integrate both sides to get the solution. So if I integrate this, then 1 plus cos t, this will be 2 cos square t by 2, and here you will get x plus c. So now you will get 1 by 2 integration sec square t by 2 dt, and right hand side will be x plus c. 1 by 2 integration of sec square t by 2, this will be tan t by 2, and in integration we have to divide by the coefficient of t, this will be x plus c. 1 by 2 will cancel, finally you will get tan, and in place of t now we have to substitute x plus y, because our original differential equation is in the form of x and y. So I will get tan of x plus y by 2, this equals to x plus c, and this will be the solution of given differential equation. So here you can see that you cannot directly separate the variable, but once you have done this substitution, x plus y equals to t, then you can easily separate the variables. So we have one more problem based on this variable separable method, so that we'll discuss after this problem. Okay, so the next problem that we have on the concept that we have learned just now is this question was asked in GATE 2017. The problem is the solution of this differential equation dy by dx is x plus y minus 1 squared is, 4 options are given. Option A is with plus sign, option B is with minus sign, option C with plus sign, D with minus sign. So we have to find which one of these function is the solution of this given differential equation. Now again, as you can see, you cannot separate the variables here directly. So the given differential equation here is dy by dx, this equals to x plus y minus 1 square. Now since you cannot separate the variables directly, in place of x plus y minus 1 you have to write t, because now this right hand side is function of x plus y minus 1. So if I write x plus y minus 1 equals to t, then we also need to replace dy by dx. For that, if I differentiate this relation, I will get 1 plus dy by dx will be dt by dx. So this means dy by dx will be dt by dx minus 1. In place of dy by dx, we can write dt by dx minus 1. So now our differential equation will be, this is your equation 1. So now you can write this differential equation 1 as, in place of dy by dx, we need to write dt by dx minus 1. So dt by dx minus 1, and our right hand side will be x plus y minus 1 is nothing but t. So this will become t square. From here you can write dt by dx. This will be t square plus 1. dt by t square plus 1. This will be dx. Once you have separated the variable, you can integrate both sides. So integration of this will be tan inverse t. Integration of x will be x plus c. So this means that t will be nothing but tan of x plus c. T was nothing but x plus y minus 1. So this will be tan of x plus c. So finally our y will be 1 minus x plus tan of x plus c. So now you can see that option A and B are with tan inverse x plus c. So this is incorrect. Option C is with plus sign here. Option D is with minus sign. So you can see that y is 1 minus x plus tan of x plus c. So this minus sign is nothing but option D. So for this question the correct answer is option D. Now after this we'll talk about homogeneous differential equation.